Hello my dear students, I am P. Madhara, lecturer in physics in continuation of our video lectures. Today we are going to discuss problems in work for energy, recently appeared NEET questions. Okay. Now in this work for energy chapter, we have got basic formula like work done. What is work done? F dot S we have, Fs cos theta. F theta is the angle between F and S. When theta is equal to 0 degrees, when force and displacements are in the same direction, then angle is 0, then work done is equal to cos 0, that is 1, W is equal to F into S we have. Work done is maximum. When theta is equal to 90 degrees, Fs cos 90 is 0. So suppose a man carrying some load on his head and moving like this, then theta is 90 degrees, then work done is Fs cos 90 is 0, so work done is 0 here. Okay, like this you have. Next we have the work energy theorem. The work done by a constant resultant force always equal to change in kinetic energy. If you know initial velocity of the body, final velocity of the body, and if you know mass of the body, then we can also calculate work done. Okay. So next, after work we have got power. Power is rate of doing work is called power. Power is equal to work by time. Now suppose a water is lifted from a well through a height h. G is the acceleration due to gravity. Then what is suppose in time is given in 1 minute like this. Then power is equal to mgh by time. Now in some cases mass of the water will not be given, dimensions of the tank will be given. In that case 1 cubic meter is equal to 1000 kg. And density of water is also 1000 kg per meter cube. Okay. And next in some problems they say efficiency of the engine. Say efficiency of the engine is 60%, they say. Efficiency means energy used like. So 60%. 60 P by 100 you should take. In some cases they say 30% of the energy wasted. 30% of energy wasted means what is remaining? Total 100% energy. In this 30% energy wasted means 70% energy is used. So like this you have to use these problems. Okay. W is equal to wasted energy, efficiency given means like this you should do. And next we have power is equal to force into velocity, also we can write. Power is equal to F dot V. This is also another formula. F dot V means you get a magnitude value only you will get. Okay, dot product you have to apply. Now coming to a very first problem here. A force of yours F is equal to 20 plus 10y acts on a particle in y direction where F is in newtons, M is in meters. Then find the work done by the particle when it moves from y is equal to 0 to y is equal to 1 meter is. Options here 20 joules, B 5 joules, C 25 joules, D 20 joules. So now it is a force changing with displacement, no variable force we call it as. Now here dW is equal to Fdy. To use integration formulas. Here limits are there, 0 to, what are limits? 0 to 1 meter. Now dW integration is W. Here some small formulas here. dW is equal to W. Integral of x to the power of n is equal to x to the power of n plus 1 by n plus 1. Another formula. And f of x, a to b, limits are there. F of b minus f of a. Upper limit minus lower limit you should take like this. So these three formulas we are going to use now. Integration of dW is W. Okay. Now W, here what is f value? 20 plus 10y dy integration. So integral of 1 dy means it is y. Okay. Now here you got like this. Limits are 0 to 1. 0 to 1. So here you get integration 20y plus 10y square by 2. Limits are 0 to 1. If you observe now, 0 to 1 are the limits. So upper limit how much here? 20 into 1 plus 10 into 1 square by 2 minus lower limit is 0. 20 into 0, 0 only. Minus 10 into 0 by 2, 0 only. This all cancel here. So this is 5. So 20 plus 5. How much? You get 25 joules is the answer. Work done will be how much? 25 joules. Okay. 25 joules. 25 joules. Okay. This is the third option is correct. Okay. 25 joules. Okay. Next question we have. Next question is, a particle is released from a height s, from height s, from the surface of the earth. Surface of the earth. At certain height, its kinetic energy is 3 times potential energy. Ke means kinetic energy is 3 times potential energy. P means potential energy. Then the height from the surface of the earth and next is the speed of the particle at that instant. The speed of the particle at that instant. Okay. Now the values are given here. S by 4 comma under root 3g s by 2, B s by 4 3g s by 2, C s by 4 under root 3g s by 2, D s by 2 under root 3gs by 2. Like this you have. Now, you know, from conservation of energy, what you have? Total energy always constant. Total energy always constant. So here it is falling from a height S. Okay. At the certain instant, at this point we will take. At this total energy, how much here? mgs. We will keep like this only. Suppose at the point A, at certain instant, he said no. At the certain instant, what he said? Kinetic energy is equal to 3 times potential energy. This is a condition. The first condition. Now you know what is total energy. This is on the surface of the earth. The height he is asking height h. Okay, height h from the surface of the earth. This you need to calculate. In terms of S you should calculate. So total energy is equal to potential energy plus kinetic energy. So at this point we have got only potential energy, no? Total energy is mgh, which is also equal to potential energy. Okay. So here kinetic energy. So here if you take total energy minus potential energy is equal to kinetic energy. But what is the condition here? Kinetic energy is equal to 3 times potential energy, no? Kinetic PE plus KE. Here KE is equal to PE plus KE, which is equal to 3 times potential energy, no? PE plus 3PE. But what is total energy here? mgs, no? mgs. So 3 times means 4 times potential energy. That is height how much here? h. So what do you have here? So here mgs is equal to 4 into mg h you will get. So mg getting cancelled. H is equal to S by 4. H is equal to S by 4. Now this is the first situation. Next what do you have? Now here what is it? Velocity. Velocity is v square. It is falling freely, no? Here v square is equal to 2g into h minus s minus h. Remaining height how much? Remaining height will be s minus h, no? At that instant, at this point he is asking. So distance travelled by this particle how much here? S minus h. So what is h here? S by 4, no? V square is equal to 2g into s minus s by 4. So what do you get here? 2g into, take LCM here, 3s you will get, 4s minus s. So 2 to cancel. So what do you get here? G also there. So here 3gs by 2 you will get. So V value how much here? Root over 3gs by 2. This is the option. First option correct. See here once again. In the conservation of energy problems, total energy always remains constant. At some point, highest point you got potential energy, at lowest point you got kinetic energy, in between both potential energy and kinetic energy. Suppose we assume that in between the point, suppose total energy at this point is potential energy only, mgs. Now in this situation here, the point A, kinetic energy is equal to 3 times potential energy set, that condition. So but general condition will take total energy is equal to potential energy plus kinetic energy. So if you go for here, total energy minus potential energy is equal to kinetic energy. But what is the given condition? Given condition is here. Total energy is equal to potential energy plus 3 times potential energy. But here mgs is the total energy, 4 times potential energy at the height h. So here at this point we want to know. So h is equal to, you got s by 4. Then the second situation, this first situation, v square is equal to u 0, initial velocity 0. So v square is equal to 2g into s minus h. Already total height is s. So here H is the height from the ground, remaining height will be S minus H. So S minus H here. H is how much here? S by 4 you got. Substitute here, you get 3gs by 4. If you take V, under root 3gs by 2 is the answer. First option is correct. Next. Third problem. Third problem is water falls from a height of 60 meters at the rate of 15 kg per second. To operate a turbine, Now the question is, the losses due to frictional forces are 10%. Frictional forces are 10% of the input energy. How much power generated by the turbine? How much power generated by turbine? You know what is turbine? A rotation, like water is falling on this will rotate. Okay, this turbine will rotate. Water falls on this like this. Water falling like this will rotate. It will generate current. So you know, G you take it as 10. Here options given here. 7.2 kilowatts. B 7 kilowatts, sorry. 10.2 kilowatts. C 8.1 kilowatts. D 12.3 kilowatts. So in the beginning of session I told now 10% of the input energy losses are 10%. How much remaining? 90%. So if you go for this solution here, 90% of the energy used, 90 P by 100 is equal to mgh by time. Now mass by time is given. 90 P by 100 is equal to mass by time how much? 15 into 10. Height how much? Height 6 meters. 6 meters. Then power is equal to 15 into 10 into 6 into 100 divided by 90. Divided by 90. 100 getting cancelled. 3 2s are 3 3s are 3 5s are. Okay. Now what you have here? 15, no? Turbine energy how much you got? Sorry, 90 P by 100 you should take here like this. Sorry, I missed out here. 90 used, no? Used power is equal to 90 by 100 into mgh by time. I will get like this. 90 by 100. Mass how much given? 15 by 15 kg. G 10. Height 6 meters. All right. Cancel. So 15 is 90, 80, 81. 8100 watts. 1 kilowatt is equal to 1000 watts. Divide this. Power is equal to 8100 by 1000. Cancel. 8.1 kilowatts. This is the answer. Okay. 8.1 kilowatts is the answer. Okay. Thank you.